Hi friends, in this particular video I am giving you a brief idea about how 8086 is interfacing with 8-bit input as well as output port at a time. So in the previous videos I explained only either input port or output port, how 8086 is interfacing with only 8-bit or 16-bit input port or only 8-bit or 16-bit output port. Whereas here let us see both 8-bit input port as well as output port, both are interfacing to 8086 at a time. Okay, right, let us see how we can analyze. See here, so here also we are taking two ports. One is called as an input port. So the role of input port is simply receiving the data from the input device and transmitting same data to processor. Okay, similarly let us see output port. So this is output port. What is the role of output port? Output port simply receiving the data from the processor and transmitting same data to output device. Okay, the name of input port is buffer and the name of output port is latch. Like that we know. Okay, now let us see, for example, how both input port and output port both are interfacing to 8086 at a time. Okay, right. So see here. Let us see here interfacing 8086 with 8-bit input port in IO mapped IO. Interfacing 8086 with 8-bit input port in IO mapped IO. Okay, so we have two mapping, IO mapped IO and memory mapped IO. Let us see IO mapped IO. Again, we have two types, direct addressing mode and indirect addressing mode. Now this diagram is for direct addressing mode. Okay, here how many address lines are present? 8, A0 to A7. Okay, direct addressing mode. Now let us see here we have one buffer that is act like a input port and one latch act like a output port. Okay, see what is the ID for buffer? It is a 74LS244. Similarly, the IC number for latch is 74LS373. Okay, for decoder also 74LS373. Okay, this is okay. 74LS I think 354 is the address for the decoder. Okay, in the I think before video I explained the decoder IC numbering. Just verify once. Okay, like that we have three different ICs. Now coming to buffer. Let us see what is the role of buffer. Buffer simply receiving the data from the input device and transmitting same data to processor. Here I am taking 8 switches, S0. Okay, only one switch he mentioned, but like that 8 switches are there, S0, S1, like that up to S7. Here S0, similarly like a dotted line up to S7, like that 8 switches are there. Okay, now each switch is connected to resistance and voltage for limiting the current. Like that 8 switches are connected to 8 data lines of the input port, nothing but D0 to D7. So then buffer also having 8 output lines, O0 to O7. These output lines are connected to lower byte of 8086, lower byte of 8086. So after receiving the data from the input port, the lower byte of the processor transmitting same data to latch. Here there is a path like this. Okay, so whatever it may be the data that is coming from the input port, nothing but from the buffer, same data is transmitted to latch with the help of data bus lines. So it's now transmitted to latch. So what is the role of latch? Latch will take the data from the processor and same data is transmitted to output device. Nothing but here we are using LEDs are the output devices. Here also what are the output lines? O0 to O7. So O0 to O7 are connected to 8 LEDs, L0 to L7 through resistance and voltage. So with the help of resistance and voltage we are controlling the current in each LED. Okay, so like that simply buffer receiving the data from the keyboards and that information is given to lower byte of the processor and processor transmitting same data to latch and latch will take that information from the processor and transmitting the same data to LEDs. Accordingly LEDs will control. So based on the here processor performs two functions at a time. It will control the switches, on and off of the switches are controlled by processor and similarly LEDs L0 to L7 also controlled by processor at a time. Okay, in the program we'll see in detail. Let us see for buffer there is activating signal is OE bar and for latch activating signal is LE. Here also we observed here because buffer performing read operation and latch performing write operation. For that we have read bar, write bar and M by O bar. So it's IO operation, that's why M by O bar must be 0. Okay, for selection of IO. Read bar also 0 for buffer and write bar also 0 for latch. So now what is the now all these two are zeros. Then what is the output? IO read bar is the output. Similarly here, what is the output? IO write bar is the output. Like that we get two outputs, one from one R and other from other R. So this output is now connected to one input of R. Other input is connected to decoder. We know already decoder now provides address for the buffer and latch, and decoder having 3 input pins and 3 control pins, and these 3 must be activating. Okay, then only will get output. Y0 and Y2 both are zeros. Like that it will generate 8 outputs, but here only 2 devices are required. 2 devices are present. So 2 outputs are enough. That's why one output is connected to a buffer R logic. Other output is connected to latch R logic. So here now Y0 is connected to R in one input of R. IO R bar, IO RC bar also 0. Both are zeros. What is the output of R? 0. 0 give it to OE bar, it will activate. Coming to here, Y2 is nothing but 0. IO write bar also 0. But LE is it's not a bar signal, normal signal. So we need to activate, we need to give 1. For that we are connecting NOR. Because of NOR, both inputs are zeros, output is 1. 1 give it to LE, then it will activate. Like that, one decoder will activate both buffer and latch. Okay, buffer and latch, and this decoder will provide address for buffer and latch. Let us see a small program. For example, processor wants to perform mainly closing of first LEDs must glow and all switches must open. So I already mentioned, in order to close the switch we should give 1. In order to open the switch we need to provide 0. For example, similarly LED also, in order to glow the LED the value should be 0. For of the LED value should be 1. For example, processor wants to glow all the LEDs. Then what happens? We are writing like this: move AL comma 00H in 80H comma AL. Because of 00H, what happens? All switches are open. All switches are open because of 00. Then in 80H comma AL. So now in means input port now receiving 00 value. Okay. Then what is the address of input port? 80. So input port is now address is 80. That address is receiving 00 value. Then based on that, all switches are open. Next, out 82H comma AL. What is it now? AL 0000 is now sent to output port, nothing but latch. Latch address is 82H. So now latch address receiving 00 value. If you receive 00 value, what happens? Accordingly, all LEDs will glow. Like that, in one shot, switches will open and all LEDs will close. For example, reverse. For example, we want to close all the switches and open all LEDs. In that case, we simply transmit FF. Okay, like that, we can make operation easily. Okay, this is interfacing 8086 with the 8-bit, only 8-bit input port in IO mapped IO, because the number of address lines are 8, A0, A7, total 8. That's why it is called it as IO mapped IO. Let us see other one. Now see the point here. Okay, now other diagram, if you observe once, last one. Now it is interfacing 8086 with 8-bit input port in memory mapped IO. See what is the difference? Same diagram. We are not changing buffer, we are not changing switches, we are not changing LEDs. Every arrangement is same. But only thing is here we are adding additional address lines. You know, if it is memory mapped IO, how many address lines are required? 20. So we have 20 address lines here. A0, A1, A2 connected to ABC. A3, A4, A5, A6 connected to G1 bar. A7 is connected to G only. Whereas G2 bar is now connected to many address lines. All are connected to OR gate. Output of R is connected to G2 bar. Nothing but A8 to A19 all are zeros. A3, A4, A5, A6 also 0. Then only output is 0. 0 is given, G1 bar is activating. 0 is given, G2 bar is activating. Which is 1? A7 must be 1. So from A19 to A3 except A7 remaining all are zeros. A0, A1, A2 they are connected to input pins. We can give either ones or zeros as per the address requirement. Okay, right. That is one change. If it is memory mapped IO, number of address lines are 20. Other change is if it is memory mapped IO, M by IO bar signal must be high, 1. Then only we are selecting memory. But for activating these latches and buffer, we are connecting one NOT gate. Because of NOT, if M by IO bar is 1, because of NOT is what is output? 0. 0 give it to R of this, similar R of this, then output is 0. For that we are connecting NOT gate. So if it is IO mapped IO, no need of using NOT gate, and simply M by IO bar is connected to low value, nothing but 0, and number of address lines are 8 or 16. If it is direct addressing mode, 8. If it is indirect addressing mode, 16. If it is memory mapped IO, only one change is we have 20 address lines, and M by IO bar is connected to NOT gate, and M by IO bar must be high initially, because of NOT output is 0. Okay, like that we can interface 8086 with 8-bit input port as well as output port. Remaining part of the connection is the same as the previous slide only. Okay, here also simply processor receiving the data from the input port through input device, and same data is transmitting to latch. Then according to the information that is coming to processor, latch will transmit information to LEDs. Accordingly, LEDs will glow. Okay, like that we can interface 8086 with 8-bit input port as well as with 16-bit also in same way. We can add one more buffer and one more latch. So two buffers will receiving 16-bit data, two latches will receiving two buffers will transmit data to 16-bit processor, and two latches receiving their data from the processor, and accordingly we have 16 LEDs here, 16 switches. That's the difference. So in that also one decoder is enough. Okay, for example, Y0 is connected to one buffer, same Y0 is connected to another buffer. Byte is connected to one latch, same byte is connected to another latch. Like that, we can interface 8086 with 8-bit as well as 16-bit input port in IO mapped IO as well as in the memory mapped IO with this particular fashion. Okay, like that we can analyze. Okay, thank you for watching this video. I hope you understand how 8086 is interfacing with various input ports. Okay, in both IO mapped IO as well as in the memory mapped IO. Okay, if you really like, please kindly share my video to your friends and subscribe my channel. Do you have any